Super Rat Smoothies Part 11 winding down here. So we're going to just finish up our two-way ANOVA. Here's raw data. Here's our two-way ANOVA table. And we have already calculated the bracket terms, sum of squares, degrees of freedoms, mean squares. So with this video, we're going to go ahead and calculate the F ratios, also called F scores. It's a test statistic. I like to call it the calculated F because you had to do all this work to get this far. So this is going to be your calculated F from your ANOVA table. And what an F score is, it's the ratio of the between group variance to the within group variance. Okay, so this is kind of how you're supposed to think about it. If there was no between group variance, let's take, for example, our serum drug. If there was no significant difference between those rats that got 0, 10, and 20 milligrams, then the within group and the between group should be relatively the same number. So any number divided by itself would be 1. So that is, if there was absolutely no difference between groups, then it would match whatever naturally occurs from the within group. So they would be the same number, and again, we would just get a 1. So, but let's go ahead and do a couple of these. So the between group variance is represented by its mean squares. So each one of these variance rows, source of variance rows, has its own separate mean square, okay? And you're going to divide that by the within group variance, commonly called the error term, right? So between group, within group, right? Between group, within group, commonly called the error term, but we write it differently. But here's the within group error term, right? Mean squares within group. We know it's 1.7. But now we write the error term like this. Mean squares subscript S/AB. That just basically means it's the error term. It's going to be the denominator on every one of these F ratios. So for the A source of variance, factor A, the serums, we got a mean square of 100. We're going to divide it by 1.7. And that is our F ratio for the between groups of variance A. We're going to repeat the process. Between groups B, okay, the F is going to equal the mean squares of B divided by the error term again, 1.7. That comes out with a little tiny 1.2. which is pretty close to 1, and we should act surprised when we figure out that there is no significant difference between the B's, which we kind of knew already, okay? And then the interaction term is going to be the mean squares of the interaction divided by the error term again, and that's a big one. Bam. Okay, the last one, the within groups, F, is no such thing. We do not take a ratio of the within group variance because it would be within group versus within group, same number. It would just be 1. Kind of makes no sense anyway. So, but there's our F scores, and I'm going to go ahead and finish this video here. We'll finish up the video series here in 1 or 2 videos to show you how to look up these F. That's it. MGZ out.